Alrighty, so today we're going to go over the special cases of the binomials. Um, yes, want to make sure my microphone still had power. We have two special cases of multiplying binomials. The reason we want to go over these is well, the primary reason we want to go over these is because these are basically just there's special cases for like SATs or ACTs or entrance exams, but they're also mathematical shortcuts. They're special cases of they're special cases of binomial multiplication that if you run into them, like I talked about how FOIL was fast and how if you wanted to do multiplication with FOIL really quickly, that if you wanted to do multiplication of binomials really quickly, that FOIL was the way to go. There are forms of there are forms of binomial multiplication and patterns of binomial multiplication that are actually like a lot faster. And there are patterns that are a lot faster, and special cases that are a lot faster. And that's pretty much what we're going to be going over today. The first one, and they also have their own very special names. Um, I haven't looked too far ahead as to the material for like the vocabulary, but I am going to tell you what the vocabulary terms are, as well as the general cases of what they're going to do. Okay, just one side. All right, as well as the general cases of what to look for, and and basically how they work. So this first one is what's called a perfect square. So, and why does a perfect square matter? Why does it matter that you're talking about a perfect square? Well, perfect square, a perfect square is, I can, so for practical reasons, let's say that I'm doing FOIL and I want to solve through and I want to solve through, hang on, and I want to solve through FOIL as quickly as I can. Like I said, hang on, and I want to solve through FOIL. And I'm given this problem. Now, hang on. There we go. Now I'm going to go through FOIL. Now I'm going to go through the FOIL steps. First, outside, inside, last. I'm going to go through FOIL with this problem, and I'm going to talk through it as I go. So, yeah, and I'm going to see how long it takes me. It shouldn't take me too long because FOIL's pretty fast. But I'm going to, you know what, I'm even going to handicap. I'm even going to give myself a little bit of a boost here. X minus 4 times x minus 4. So this is an example. This is an example of this is exactly what this is. X minus 4, x minus 4. I'm going to use the FOIL method, and let's see how this works. So first gives me x squared outside minus 4x inside minus 4x last plus 16x. That gives me x squared minus 8x plus 16. Final answer, stop. All right, not bad, right? I mean, a little bit of issue with penmanship, of course. A little bit of issue with penmanship, but yeah. So 16 seconds with 16 seconds using FOIL, not bad, right? And keep in mind, I'm just talking about practical cases. I'm just talking about practical solving problems. Um, just getting through the day. Oops, no, just practical getting through the day solving problems. Perfect squares have their own forms. If you see a perfect square, it means that you're basically able to apply a solution to it immediately. You see it, you know what the solution is, and the answer is basically right there. Um, yeah, so let's see. What is the solution of a perfect square? So, um, yeah, so the solution for a perfect square is going to be x squared. For this one is going to be minus 2ax minus a squared. And this is going to be your x. This is going to be your a. So, really quickly, I basically have been stalling and not looking at the screen and not looking at the paper, not looking at the part of the paper that has the answer on it. So it was in my short-term memory. I don't really remember exactly what it is. I could probably, anyway, I can work it, I can kind of work it out if I really need to, but all I remember is like yeah. Anyway, I apologize for the delay. I'm basically delaying it so that in my short-term memory, so that the answer that is up here somewhere, I'm not even looking at the screen, it's no longer in my short-term memory. So, yeah, let's go ahead and with the special cases of the perfect square, let's see how long it takes me to solve this one. Hmm. Well, wouldn't you know it? Like I said, Um, all I knew, all I remembered from this is that this is a perfect square. I knew that the second term was 2 times what this was. I knew that the third term was this term squared. And that's the formula for a perfect square. Like I mentioned, I wrote it down before. The formula for a perfect square, practically speaking, is x plus minus a squared. And that will lead you to either, if it's plus, x squared plus 2ax plus a squared, or x squared minus 2ax plus a squared. All right, thank you very much, research assistant. All right. So yeah, like I said, I apologize for the delay, but I was basically trying to get this out of my short-term memory. Because I remembered this, I know this because I've used this before because I took the SATs so many times. But I needed to get this answer out of my short-term memory, and so that's why I delayed as long as I could just so I could get this one done. So just for practical purposes, it makes doing a lot of these problems very, very easy. Um, but the the real value behind the perfect square you basically get into when we start talking about quadratics and we start talking about graphing and we start talking about graphing and quadratics and parabolas. But for right now, what you need to remember is that perfect squares, if you see them, are they're basically very easy to solve. And like I said, there's a lot more to them in theory. But we're not going to be doing a lot of but I mean we're not going to be doing a lot of graphing to it. Well, I mean we're literally not going to be doing graphing. I mean, that's literally it. We're not going to be doing a lot of graphing. It's we're short circuiting FOIL with very specific examples with very specific circumstances. Um, yeah, this is just more or less a foundation that this is more or less a foundation um, to introduce you to the perfect square. And the next case, which we will go over, that I will definitely not take as much time on. But like I said, I don't want to overload you with all the stuff that perfect square has about it. As far as I know about this particular unit, the perfect square is an exception to the FOIL rule, so that it is an even faster way to do FOIL problems. The next one is what's called a difference of squares. And oh, there we go. And this one is, I don't want to say easier, but this one, the big thing you want to look out for is that it's It's plus an element and minus it's plus an element and minus that same element. And just kind of like how just kind of like how the perfect square had its own special rule over here that you can remember, that you can memorize, that always works out. This one also has the same rule. And honestly, it's a lot easier to remember. Um, if you have x minus a, x plus a, it is always going to equal x squared minus a squared. You know what? I'm going to write this down on. I'm going to write this down on the side of the worksheet where I have the special case here. So if you have, and what I'm going to do is I'm going to use the box method up on top, and we're going to, we're going to multiply everything through using the box method, and we'll see what the final result is there. But if you have x plus a and x minus a, that is always going to equal x squared minus a squared. So up here, depending on whether you had plus minus a, for the perfect square, you would get plus 2ax or minus 2ax. No big deal, right? Down here, if you have plus minus in the multiplication, you will always get x squared minus a squared. And it's called the difference of squares. All right, so like I said, x squared minus a squared is always going to turn out this way. So I've got x minus 5, x plus 5. I'm just going to write up here x squared minus 25, because that's the difference of squares space. That's the difference of squares answer. And I don't have enough space, I don't think, to really do a good box for the box method. So I have this. And then I know it's x plus 5. And then I've got x minus 5. All right. That gives me x squared, x times 5, so that's 5x. Minus 5 times x is minus 5x. Minus 5 times 5 is negative 25. So that gives me x squared, 5x's cancel, minus 25. Oh, well, there we go. X squared minus 25. You know what? I'm pretty sure that's a fluke. And I've wanted an excuse to use the FOIL method and the box method on the exact same problem, because I think that the FOIL method is better and it'll give you the correct result as opposed to this box method, which is just silly. I've just always thought it was silly. But let's just do this using the FOIL method. So I've got first, which is x squared, outside, which is 5x, inside, minus 5x, and last, minus 25. Cancel out the terms, and then x squared minus 25. Oh, well, this is a little embarrassing, but it's not, because it is a difference of squares. That is always what the answer is going to be, regardless of your factoring method, or regardless of your factoring method or your technique or what have you. And the difference of squares, much like perfect squares, it has a lot to do with algebra and graphing moving forward. But this is really just kind of an introduction. And what it comes down to is this is an introduction and a special case for multiplying binomials that should short circuit FOIL and make things go a lot faster for you. So in this case, now that we're actually working on the examples, this should go pretty fast. Y plus 8 minus 8, it should give me y squared minus 64. But let's try. I'm going to do FOIL on this side, and I'm going to do box on this side. So FOIL is y squared, the first, and then outside minus 8y, inside plus 8y, then last minus 64, 8y, y squared minus 64, okay? K plus 5 squared. All right. I know using the perfect square that this is going to be k squared plus 10k plus 25. But how can I really know until I use my box method? 5. So k times k is going to be k squared. K times 5 is going to be 5k. 5 times k is going to be 5k. And 5 times 5 is going to be 25. K squared times 10 plus 10k plus 25. Well, all right then. Let's continue forward. So I'm going to shake this up a little bit. I'm going to use the box method on this one because it looks like all of these are going to be the same type of problem, and I want to bounce it back and forth between the box and the FOIL method. So I'll use the box method on this one just to kind of shake things up a bit. So this gives me 5x and 7, and then 5x minus 7. And just for my edification, this should be 5. So this should be 25x squared minus 49. So that's just doing the shortcut. That's just doing the difference of squares shortcut. So that's 25x squared, 35x minus 35x minus 49. So 35, 35. So that's 25x squared minus 49. Alrighty. Well, I mean, it's okay. We're pretty good there. Okay, so we've got a perfect square here, so that's 30, so this one should be 36a squared plus 4, it's plus 2ax, so it's plus 12, at plus 12a plus 4, so all right, plus 12a plus 4, yeah. Yeah, I think that's worked. So we'll do the FOIL method. So it's kind of need it written out this way to be able to do the FOIL method. So 6a and 6a is 36a squared. 6a and 2 is 12a. That's right. Anyway, it's 12a plus 12a and then plus 4 equals 2a. Hmm. Hmm. Well, isn't that something? Plus 2. So this gives me 36a squared plus 24a plus 4. I'll tell you what's throwing me off is that the mnemonic over here is also in a. And so it's x squared plus a x. So it's x squared plus ax. So, oh my goodness. Oh my goodness. So it's not just 2, it's 6. All right. So the 2a, so this one is supposed to be, so this is 2ax. Okay. So this term here is supposed to be 2ax for the shortcut. So this middle term is supposed to be 2ax. I made an arithmetic mistake because I was trying to do it quickly because I wanted to be faster than FOIL. So it's supposed to be 2ax. So it's supposed to be 2 times whatever a is. So that's 2 times 2. And then it's also supposed to be whatever the coefficient for x is. So again, what threw me off was that a is the variable here, but it's also but this is the number 6 that's supposed to be here. So 2 times 2 times 6 is 4 times 6, which is 24. Because 6 times 6 is 36, and then 2ax times 2 times x is 24. Yeah, I went too quick. I went too quickly. I flew too close to the sun. tried to outpace it when I should have just gone with it. You know what? For my penance, foiling this one. So let's get started. With this one, the answer should be 64h squared minus 9. All right. First of all, so that's 64h squared outside plus 24h inside minus 24h last minus 9. Yep, yep. 64h squared minus 9. Oh, there we go. All right. Last one. I'm going to use the box for this one. I haven't used the box in a while. May as well. So 3y negative 2, 3y negative 2. So before I go anywhere, before I use the box method, I'm going to try to use the shortcut methods and not throw myself off. So it's going to be x squared. So that's going to be 3. So it's 9y squared. So 9y squared minus 2ax. So minus 2 times 3 times 2. So minus 12y minus a squared. So that's plus 4. Okay. All right. I think I've got this. I think I've got it all right. So 3 times 3 is 9y squared. 3 times negative 2 is going to be negative 6y. Negative 2 times 3y is going to be negative 6y. Negative 2 times negative 2 is plus 4. So I've got 9y squared minus 12x plus 4. There we go. Woo! I talk a lot of smack about the box, but you know what? The box saved me. I just need to, well, what I need to do is practice these shortcuts. All right, so so this time I'm just going to use the shortcuts. I'm not, by now, hopefully we've established that these rules work using the FOIL or the shortcuts, using the FOIL or the box method. So I'm just going to go through and try to set this up here. So 3x minus 6, so this is a perfect square. So that's going to give me 9x squared. Minus, because it's minus, so it's 2 times a, so it's 2 times 3 times 6, so 2 times 3 is 6 times 6 is 36, plus 36. Okay, I got to verify this. I've got to verify it. And yes, I'm verifying it with a box. Okay, we're good. We're good. All right, we're good. Now this one I don't have a problem with. The difference of squares I've never had an issue with. This one's going to be a squared minus 36. This one these ones I've never had an issue with. And technically I never really had an issue with the perfect square one. I just one time forgot to put the a coefficient with my multiplication because I was running through it too quickly. But anyway, yeah, perfect squares and difference of squares. Uh, I guess this is just the formal introduction to them, and they're going to be really important and they're going to be really key moving forward with different types of mathematics. And like I said, I didn't want to overload anybody with them, but yeah, they're going to be important, and we're going to have to work around them and work using them. So yeah, hope you paid attention. If not, just hit rewind.